As you might have guessed, let's talk about light and plants. So the very first question is just, why? So this is it. The equation, the formula upon which all our life is based. Photosynthesis. So we have carbon dioxide plus water. The plant then turns into sugars and oxygen. Carbon dioxide, water, becomes glucose and oxygen. This glucose itself forms the basis of cellulose, which is the structure of plant cell walls, which is just the absolute minimum needed for growth. So for a plant to grow, it needs these sugars to make their cell walls to grow, to make more of itself. And so it actually seems like maybe, this sugar is the most important part, but we have a big unknown that we've just been glossing over. This light is actually driving this equation. It provides the energy to the plant to take a gas and a liquid, or just these two kinds of molecules, and turn them into something else entirely. To break these apart to liberate oxygen and to capture the carbon and some of the hydrogen and oxygen, but really just to capture the carbon and to turn it into this glucose to fuel itself, to grow. This is why plants have leaves. Plants have leaves to act as solar panels to capture this light energy, to create sugars to fuel their own growth. Once we move into a more controlled environment, we can start controlling this light energy. Also, sometimes we begin to restrict how much sunlight there is for the plant to use, and so we need to start supplementing this light energy. Plant production is based on the light that it receives, and so a good plant producer is going to try to control and optimize the light those plants can get. And this can change even in the best of circumstances. We have this weather, we have the summer versus the winter sun. Maybe it gets cloudy, maybe it starts raining. All these things can be reducing the amount of light that's coming and hitting the plant, right? So if we just, do I need to draw that out? If clouds come in front of the sun, the plant gets less light. If the sun is lower in the sky or out for fewer hours, the sun or the plant gets less light. If there's rain, background into the clouds, the plant's getting less light. So all this time, the plant isn't growing as much as it could. So what are some ways that we can both track these variables to then make the most of the light that we're trying to manipulate and give these plants? Well, luckily, we have this study from these scientists. These are their names. This is the DOI if you want to find it itself. But basically, what these researchers did in their article was to investigate this 24-hour circadian rhythm, the standard photo period for plant growth. Right? We have sun during the day, no sun during the night. Well, they found that, of course, plants are growing while the sunlight's hitting them, and then not when the sun isn't hitting them. However, if you change the scenario, they found that they could run lights on plants for an additional 24 hours, making it 48 hours, and then an additional 24 hours, making it 72 hours. They ran artificial light over the entire period and found that plant growth continued to increase up to a full 3 days. So plants grew as you gave them more light. We found more growth. More light, more growth, up to a 72-hour limit. As plants received more light, they continued to grow. After this point, the plants crashed and couldn't handle it anymore. So as they started the experiment, of course, the plants started at the same size, and the first 12 hours of light, the plants grew the same amount. This plant, under a typical diurnal cycle, grew the expected amount for 3 days of growth on the crop. However, during the 72-hour extension, the plant was growing to those heights sooner, and ultimately growing more in the same time period as these other plants. So we're starting to unlock some potential here in this controlled environment. We supply light to these plants and they grow beyond natural limits. Now, as I pointed out, if they continued to give it more light, then the plant actually began to decay and kind of fall over, flop, get spent, because just like you and I, plants need rest to recover their systems and for this growth to continue. So what's the best way to maximize growth, given that we know that plants can grow more than a day, more than natural light conditions? How do we increase that without losing our crop? Well, they came up with a solution. So first you've got your source of light, whether it be the sun or artificial light, and then you need some kind of monitor, some kind of light sensor to measure how much light is coming in, connect that to a computer, and ultimately we are tracking DLI, daily light integral. It's a measure of how much light has reached a certain source. And now finally the calculation happening on this computer. It can either be a 3-day running average where this light is measuring income, or this sensor is measuring incoming light as it happens, naturally across these 3 days. How much light came in here, how much light here, and how much light here. And it just is averaging them so that add another day. This 3-day average means that we'll calculate an average for this, and this to get our first average. Then we'll calculate this one, and this one to get our second average, and so on. And so you're just constantly, you have this rolling average, so that across each day you're never measuring any one in particular, but you're saying the past 3 days it's been very sunny, or maybe the clouds came in on this day. And so you'll see this one accounts for the cloudy day, this one accounts for the cloudy day, but as soon as we get one more day beyond, now that cloudy day is behind us. And so this average kind of gives us, again, never a particular day's measurement, but just this rolling average to kind of let us know how much the crops are getting across time. And as weather fades into the background, our average comes back to reflect what's been happening. The other version is constant monitoring. And then this would, of course, use this sensor to track how much light is coming in just at every chunk, whatever interval you want to set, maybe every hour, like that. So your constant monitoring is going to tell you, like right now, sunshine. Right now, like all these are sunny. Then it was dark. Then it was kind of cloudy. Then it was dark. Then it was sunny. Then it was dark. So it's just, like the constant monitoring is basically you looking outside of your window. However, when you're connecting it to a logging device, something that can average it, something that can also pair with triggers to artificial or supplementary light, what happens is that you can now react. What light you've been getting from the sun, is it not enough on this cloudy day, whether you had the 3-day average or the constant monitoring? This cloudy day, it would trigger lights to come on. And this is the whole point, so that we're not just relying on natural. When the sun's out and we're getting good sun, awesome. Getting good light, awesome. When it goes cloudy, we kick on these lights and bump these averages, or this constant monitoring, whichever one, get that to come back up so that we are keeping these plants at maximum production. How do you make the choice between these two approaches? Well, luckily they helped us out with that too. So the 3-day rolling average typically over applies light and so costs more money. The constant monitoring tended to under apply light and so yield less crop. So it's just kind of two different versions. Less light costs less money, you get less crop and you get less money. More light costs more money, but you get more crop and you get more money. Whichever one you want to do, honestly, constant monitoring is the easiest. So just setting up something that just monitors how much light's coming in. Does it hit how much you need? Yes, no lights turn on. No, turn on the supplemental lights. That's as simple as it can be. Once you roll in the 3-day average, well, then you got to calculate the averages, and then it complicates matters. So I suggest if you automate I suggest you automate your light sensing, light recording, so you know how much light is hitting your crops. And for another, I suggest you pair it with constant monitoring to trigger supplemental light.